All right, let's dive in. Today we're all about coding. We're taking a deep dive into this Algo Academy blog post, how to start learning to code from scratch.
Yeah, it's a great guide. It's perfect for anyone who is, well, starting from scratch.
Exactly. And you've been coding for what, like a decade now?
Something like that, yeah. But I still remember those early days. It can be a little overwhelming at first.
Absolutely. So today we're going beyond those basic how-tos. We really want to explore those whys, like why even bother with coding?
Yeah, and also like those what nows, like, okay, you've learned the basics. Where do you even go from there?
So many paths to explore. But let's start with that why. I mean, a lot of people think coding is just for like tech geniuses who want to build the next big app.
Right, but it's so much more than that. This post actually highlights a bunch of benefits beyond, the obvious career opportunities.
Yeah, like it mentions how coding can boost problem-solving skills, even in like everyday life.
Totally. Coding forces you to think logically, break down problems into smaller steps, and come up with creative solutions. And it's not just theoretical, it's practical too.
Oh yeah. Like remember last week you were telling me how you automated that whole process of like renaming and organizing all your photos.
Oh my gosh, it was a lifesaver. With a bit of Python, I whipped up a script that did it all
And
automatically.
that's what I'm talking about. It's like having your own personal robot assistant. And that's just one example. The post also talks about using coding to like analyze data, automate repetitive tasks.
Even create art and music. The possibilities are kind of endless.
Absolutely. But before you get carried away with all those cool possibilities, the Algo Academy post really stresses setting smart goals.
So important. Otherwise, it's easy to get lost in the vastness of coding.
Right. Smart goals are like, specific, measurable, attainable, relevant, and time-bound.
Yeah, so instead of just saying, I want to learn to code, which is way too broad.
You could say something like, I want to build a basic website using HTML and CSS within 3 months.
Now that's a smart goal. You have a clear objective, a time frame, and it's achievable.
Exactly. So you set your goal, you're pumped and ready to go. But then comes the big question. Which programming language to start with?
Ah, yes, the age-old dilemma. And this post actually dives into that too.
It recommends starting with either Python or JavaScript.
Both are incredibly popular and versatile languages with tons of resources available.
But how do you know which one's right for you?
Well, the post suggests aligning your choice with your goals. Like, what are you hoping to achieve by learning to code?
Right. If you want to build websites, for example, JavaScript is pretty much essential.
It's the language of the web, as the post puts it.
Makes sense. But if you're more interested in things like data analysis, automation, or even artificial intelligence,
Python might be a better fit. It's known for being beginner-friendly and super versatile.
okay, so JavaScript for web, Python for broader applications. But like, you don't have to limit yourself to just one language forever.
All right. Not at all. Once you've mastered one, learning others becomes much easier. The underlying concepts are often similar.
It's like learning, I don't know, Spanish and then trying to learn Italian. There are definitely some similarities.
Exactly. So don't stress too much about picking the perfect language right away. Just dive in and start experimenting.
The post lists a bunch of different learning resources. You've got online courses, coding boot camps, interactive platforms, and, of course, good old-fashioned books.
It's all about finding what clicks best for you. Some people thrive in structured environments, while others prefer a more self-directed approach.
Totally. But regardless of how you learn, the post really emphasizes the importance of building those strong foundations.
Absolutely. It's like building a house. You need a solid foundation before you can start adding those fancy features.
I like that analogy. So what are those foundational concepts?
Well, the post breaks down some of the key ones, like variables, control structures, functions, and data structures.
Okay, let's start with variables. Those are like the basic building blocks, right?
Exactly. Think of them as containers for storing information in your code. Like you could have a variable called name to store someone's name or age to store their age.
Makes sense. And then control structures. Those sound a bit more complex.
They're not too bad once you get the hang of them. Basically, they control the flow of your code, allowing you to make decisions based on certain conditions.
Okay, so like an if statement, like if this condition is true, then do this, otherwise do that.
You got it. Those are control structures in action.
Cool. And functions. Those always kind of tripped me up when I was first starting out.
Functions are like reusable blocks of code that perform a specific task. So let's say you need to calculate the area of a rectangle multiple times in your program.
Right.
Instead of writing the same code over and over again, you could create a function called calculate area that takes the length and width as input and returns the area.
So it's like creating a shortcut for a set of instructions that you'll be using multiple times.
Exactly. It makes your code more efficient and organized.
Awesome. And then finally, data structures. Those always sounded a bit intimidating to me.
They can seem that way at first, but they're super useful once you understand them. Think of them as different ways to organize and store data in your program.
Okay, so like instead of just having a jumbled mess of data, you have these specific structures to keep things tidy and make them easier to access.
Exactly. There are different types of data structures, each suited for different purposes. Like arrays are great for storing ordered lists of items.
Okay,
Dictionaries are like key value pairs, so you can quickly look up a value based on its key.
got it.
And lists are more flexible, allowing you to add and remove items as needed.
So it's like choosing the right container for your data.
Precisely. And understanding these core concepts is super important as you start building more complex programs.
It's like having the right tools for the job. You wouldn't use a screwdriver to hammer in a nail, right?
Exactly. And the post even provides a snippet of Python code to illustrate how these concepts all work together in a simple program.
I always find it helpful to see actual code examples. It makes those abstract concepts feel more concrete.
Totally. And the post actually goes one step further and even touches upon version control, which is a crucial tool for any serious coder.
Version control. That sounds a bit intimidating.
It might sound complex, but think of it like a time machine for your code.
A time machine.
Yeah, it allows you to track changes, go back to previous versions if you mess something up, and even collaborate with others on the same code base without stepping on each other's toes.
So, like, if you make a mistake, you can just rewind back to a previous version.
Exactly. No more frantic copy-pasting or trying to remember what changes you made.
That sounds incredibly useful.
Yeah.
And it's essential for working on larger projects, right?
Absolutely. And there are different version control systems out there, but Git is the most popular one.
Git. I've heard of that.
Yeah, it's like the industry standard these days.
Yeah.
And the post actually provides some basic Git commands to get you started.
Perfect. So we've covered the why behind coding, the foundational concepts, and even touched upon version control. It's a lot to take in.
It is. But remember, learning to code is a journey, not a sprint.
And speaking of journeys, this post also talks about the importance of the coding community.
Yeah. The coding community is amazing. It's so supportive and collaborative.
It's like having a global network of coding buddies to cheer you on and help you when you get stuck.
Exactly. And there are so many ways to connect with the community. From online forums like Stack Overflow to local meetups and even coding boot camps.
So you can find your people both online and offline.
Precisely. And don't be afraid to ask questions. Everyone was a beginner once, and most experienced coders are happy to help those just starting out.
Okay, so we've talked about the benefits of coding, setting goals, choosing a language, building those foundational skills, embracing version control, and tapping into the power of the community.
That's a great overview of what we've covered so far.
But we've only just scratched the surface. In our next part, we'll delve deeper into those data structures and algorithms that you mentioned earlier.
The real meat and potatoes of coding. And we'll also explore how these concepts apply to real-world scenarios and even those dreaded technical interviews.
Stay tuned. All right, welcome back. Last time we kind of laid the groundwork for our coding journey, and now we're stepping into the exciting, kind of maybe a little scary world of data structures and algorithms.
Yeah, these terms definitely sound intimidating at first, but this guide actually does a really good job of, breaking them down.
Yeah, it's all about those analogies, right? Making those abstract concepts a little more relatable.
Totally. Like, the post compares data structures to different ways of organizing your books.
Oh, I like that. So instead of having like a giant pile of books everywhere,
You can organize them by author, by genre, or even color-coded if you're feeling fancy.
each method has its own pros and cons, depending on how you want to access those books.
And it's the same with data structures in coding. They provide these efficient ways to store and retrieve information, which ultimately makes your programs run smoother and faster.
So it's like choosing the right organizational tool for the job, right?
Exactly. Let's dive into some examples. We've got arrays, which are like those numbered bins you might see in a library.
Okay, yeah, I can picture that.
Perfect for storing items in a specific order. Need to access the third item. Boom, you go straight to bin number 3.
Simple as that. What about lists? Are those similar?
Lists are a bit more flexible, kind of like a backpack where you can add or remove items as needed.
So it's not fixed like an array. You could just throw things in and take things out as you go.
Exactly. And then we've got dictionaries. Think of those like your contacts list on your phone.
Where each name is linked to a unique number.
Right. Need to find someone's number. You search by their name, and the dictionary does the magic for you.
So arrays are like organized shelves, lists are like a dynamic backpack, and dictionaries are like a super efficient phone book.
Perfect summaries. Now let's move on to algorithms. Think of those as step-by-step instructions that tell your computer how to solve a specific problem.
Okay, so it's not just about storing the data, it's about telling the computer what to do with it.
It's like a recipe for baking a cake. You've got your ingredients, the data, and a set of instructions, the algorithm, that tell you exactly what to do with those ingredients.
So you could have multiple recipes, algorithms that achieve the same end goal, but some might be more efficient than others.
Exactly. Some might require fewer steps, less time, or maybe use fewer resources.
So some algorithms are like those quick and easy cake recipes, while others are more like those gourmet, multi-step masterpieces.
That's a great analogy. And the guide emphasizes that understanding these algorithms is crucial for writing efficient and scalable code.
Especially as your projects become more complex.
Absolutely. It's like having a toolbox filled with different tools. You wouldn't use a hammer to tighten a screw.
Or try to bake a cake with a wrench.
Right. Choosing the right algorithm for the task at hand can make a huge difference in how efficiently your program runs and how well it performs.
So it's not just about knowing how to write the code, it's about knowing which code to write
Yeah.
and how to optimize it.
Exactly. And the post even suggests practicing implementing these data structures and algorithms yourself, not just reading about them.
Because practice makes perfect, right?
It really does. And it also prepares you for those technical interviews where these concepts are often put to the test.
It's like practicing your scales and arpeggios before a big piano recital. The more you practice, the more confident and fluent you become.
Now, shifting gears a bit, let's talk about the vast and exciting landscape of coding careers.
Yeah, we touched upon this a bit earlier, but I'm really curious to delve deeper into those career paths and see which ones might resonate with, my interests and skills.
Absolutely. So let's start with front-end development. Think of this as the art of crafting the user interface and experience for websites and applications.
Okay, so it's like being the architect of the visual side of the website, the part that users actually see and interact with.
Exactly. Front-end developers use languages like HTML to create the structure of the website.
HTML, that's like the skeleton, right?
Exactly. Then they use CSS to style the website, making it look all pretty and visually appealing.
Okay, so HTML for structure, CSS for style. What about the dynamic stuff? The interactive elements, the animations, all those cool things that make a website come alive.
That's where JavaScript comes in. It's the language that brings those interactive elements to life, making the website more dynamic and engaging.
So if you're drawn to the visual aspects of web development, if you enjoy creating those seamless and user-friendly experiences, front-end development might be the perfect path for you.
Now let's move behind the scenes to the world of back-end development.
The engine of the car, as you said before, right?
Exactly. Back-end development focuses on the server-side logic, the databases, and all those complex systems that work behind the scenes to make a website function properly.
So while front-end developers focus on what users see, back-end developers focus on making sure everything works smoothly behind the curtain.
Precisely. They work with databases to store and retrieve information, use APIs to connect different systems together, and write code that handles things like user authentication, security, and all that critical stuff that users might not even realize is happening.
So it's like the brains of the operation, making sure all the pieces fit together and work seamlessly.
Exactly. Backend developers often use languages like Python, Java, or PHP. It really depends on the specific needs of the project.
Now, what about full-stack development? That's the one where you kind of do it all, right? Both front-end and back-end.
You got it. Full stack developers are like the superheroes of web development.
They can handle everything from designing the user interface to writing the complex server-side logic.
It's a demanding role for sure, but it's also incredibly rewarding because you get to see the entire project come together from start to finish.
So if you enjoy both the creative aspects of front-end development and the problem-solving challenges of back-end development, full stack might be your calling.
Now, let's not forget about mobile app development, a field that has just exploded in recent years.
Everyone and their grandma has a smartphone these days, and they're all glued to those apps. It's a huge market.
Mobile app development focuses on creating those addictive apps that we use on our smartphones and tablets.
From games to social media apps to productivity tools, the possibilities are endless.
And the great thing about mobile app development is that you can see your creations come to life in the hands of millions of users around the world.
That must be incredibly satisfying. What does it take to become a mobile app developer?
Well, you need to understand the specific requirements and design principles of different platforms like iOS and Android.
Because they're quite different, right?
Yeah. They have their own unique design languages and user interface conventions. So for iOS development, you might use a language like Swift, while for Android, you might use Java or Kotlin.
So it's not just about knowing how to code. It's about understanding those nuances of each platform and how users interact with them.
Now let's dive into a field that's all about extracting insights from data. Data science.
Data science, that's a buzzword that's everywhere these days. But what does it actually involve?
It's all about using statistical methods, machine learning algorithms, and your coding skills to analyze and interpret vast amounts of data.
Okay, so it's not just about crunching numbers. It's about finding the stories and insights hidden within those numbers.
Exactly. Data scientists are like digital detectives, uncovering hidden patterns, making predictions about future trends, and ultimately helping organizations make better decisions.
It sounds like a field where you can really make a difference, not just building cool things, but using your skills to shape the world around us.
Absolutely. And data scientists often use languages like Python or R, which are specifically designed for statistical analysis and data visualization.
So if you're interested in the power of data, if you're curious about uncovering those hidden trends and using that knowledge to drive change, data science might be the path for you.
Now, let's shift gears to a field that's all about efficiency and automation in the software development process. DevOps engineering.
DevOps. I've heard that term thrown around, but I'll admit I'm not entirely sure what it entails.
DevOps engineers are like the masters of streamlining the process of building, testing, and deploying software.
Okay, so they're kind of like the project managers, making sure everything runs smoothly from start to finish.
That's a good way to put it. They ensure seamless collaboration between the development teams who are writing the code and the operations teams who are responsible for running and maintaining that code in a live environment.
So they're the bridge between those two worlds, making sure everyone is on the same page and the software is delivered efficiently and reliably.
Exactly. DevOps engineers often work with tools like Docker for containerization, Kubernetes for orchestration, and cloud platforms like AWS or Azure for deployment. It's a very technical role, but also involves a lot of problem solving and communication.
Okay, now for a field that combines creativity, technical skills, and a passion for entertainment. Game development.
Ah, yes. Game development is where you can really let your imagination run wild, creating immersive worlds and characters that captivate players.
It's a dream job for many aspiring coders, myself included. What does it take to break into the world of game development?
Well, you definitely need a strong understanding of programming concepts and a passion for gaming.
That's a given. But are there specific languages or skills that are essential for game development?
Game developers often use languages like C++, C Sharp, or Lua, which are known for their performance and ability to handle complex graphics and physics.
So it's not just about writing the code, it's about understanding game mechanics, storytelling, and how to create engaging experiences that keep players hooked.
Exactly. It's a demanding field, but also incredibly rewarding to see your creations come to life and entertain millions of players around the world.
And finally, let's touch upon a field that's at the forefront of innovation, pushing the boundaries of what computers can do: AI and machine learning engineering.
AI and machine learning are transforming practically every industry, and these engineers are the ones driving that transformation.
It's like they're teaching computers to think, to learn, to make decisions like humans.
In a way, yes. They develop systems and applications that leverage artificial intelligence and machine learning algorithms to solve complex problems, make predictions, and automate tasks that were once thought to be impossible for machines.
Wow, that's incredible. What kind of skills do you need to become an AI or machine learning engineer?
Well, you need a strong foundation in mathematics, statistics, and of course, coding.
And are there specific languages that are commonly used in this field?
Python is incredibly popular in the world of AI and machine learning, mainly because of its powerful libraries and frameworks like TensorFlow and PyTorch, which are specifically designed for building and training machine learning models.
So Python is the go-to language for aspiring AI and machine learning engineers.
It's definitely a great starting point, and the field is constantly evolving, so continuous learning is crucial.
Okay, so we've covered a wide range of career paths, from front-end development to back-end development, full-stack development, mobile app development, data science, DevOps engineering, game development, and even AI and machine learning engineering.
Phew, that's a lot of options. It's like a buffet of coding careers, each with its own unique flavor and appeal.
It can be a bit overwhelming to choose, right? I mean, how do you know which path is the right one for you?
The Aldo Academy post actually emphasizes the importance of exploration and research. Dive deeper into the roles that pique your interest.
Read up on them, watch videos, maybe even connect with people who are working in those fields.
Exactly, and don't be afraid to try different things. You might start with one path and realize it's not a good fit, and that's okay. The beauty of coding is that those skills are transferable. You can pivot and explore different areas until you find your perfect niche.
It's all about that journey, right?
Absolutely.
Okay, we're back for the final part of our coding deep dive. We've explored the reasons to learn to code, gotten a grasp on some of those key concepts, and even taken a peek at all those different career paths you can take. But now, let's get down to the nitty-gritty. How do you stay motivated when things get tough? How do you nail those technical interviews? And most importantly, how do you keep learning and growing as a coder?
You know, this Algo Academy post really nails it when it talks about the importance of mindset. It's not just about the technical stuff, it's about having the right attitude.
It's like having that growth mindset, right?
Mhm.
Believing that you can learn and improve with effort.
Exactly. And the post emphasizes the importance of setting realistic expectations. It's easy to get caught up in the hype and think, oh, I'll be building the next Facebook in a month.
Right, but coding is a skill, like anything else. It takes time and practice to get good at it.
Totally. So the post suggests breaking down those big, ambitious goals into smaller, more manageable steps.
So instead of aiming to master Python in a month, maybe you focus on building a simple text-based game.
Exactly. And achieving those smaller milestones can really boost your motivation and keep you moving forward.
It's like those little wins along the way that keep you going. And the guide also mentions the importance of celebrating those aha moments. You know, those times when you finally figure out a tricky piece of code or solve a bug that's been driving you crazy.
Oh, yeah. Those moments are pure gold. It's like that feeling of satisfaction and accomplishment that keeps you coming back for more.
And it also suggests keeping a coding journal or a log of your projects.
That's a great idea. It's a way to track your progress and see how far you've come.
It's like a portfolio of your coding achievements. You can look back and see all the things you've learned and the challenges you've overcome.
Which can be super helpful when those inevitable moments of doubt creep in. Because, let's be real, learning to code can be tough, and there will be times when you hit a wall.
Oh, absolutely. Those moments when you're just staring at the screen, feeling completely stuck. I've been there.
The post has some great advice for those situations, too. One of the simplest but most effective things you can do is take a break.
Yeah. Sometimes you just need to step away from the code for a bit, clear your head, and come back with fresh eyes.
Exactly. Go for a walk, listen to some music, do something completely unrelated to coding. It's amazing how a fresh perspective can help you see things in a new light.
And don't be afraid to ask for help.
Oh, so important. Reach out to online forums, coding groups, or even a friend who's also learning to code. Sharing your struggles and celebrating your victories together can make a huge difference.
It's all about having that support system. Okay, now let's talk about those technical interviews. I think every aspiring coder gets a little nervous about those.
They can definitely be intimidating, but this post has some solid advice for navigating them successfully. The first thing they emphasize is practice.
Practice makes perfect, right?
Exactly. And those coding challenge platforms we mentioned earlier, like LeetCode and HackerRank, those are like your training grounds.
It's like training for a marathon.
Yeah.
You wouldn't just show up on race day without any practice, right?
Yeah.
You need to build up your coding stamina and get comfortable solving problems under pressure.
And the post also mentions the importance of preparing for system design interviews. Those are often part of the process for more senior roles.
So it's not just about solving coding puzzles. It's about showing that you can design and architect complex systems.
Exactly. And don't forget about the behavioral interview questions. Those are your chance to showcase your soft skills, like communication, teamwork, and problem solving.
It's about showing the interviewers who you are as a person, what drives you, and why you'd be a great fit for their team. Okay, so we've talked about staying motivated, nailing those technical interviews, and the importance of continuous learning. Is there anything else we should keep in mind as we embark on our coding journey?
I think the biggest takeaway from this post is that learning to code is a marathon, not a sprint. It takes time, dedication, and a willingness to keep learning and growing.
It's about embracing the challenges, celebrating the victories, and never giving up on your coding dreams. So there you have it. We've covered a lot of ground in this deep dive, exploring the world of coding from those first steps to those exciting career paths and beyond.
And hopefully, we've inspired you to take the leap and start your own coding adventure.
Remember, the possibilities are endless. So what will you create? Happy coding, everyone!